A ball is projected sideways from the top of a 12-meter tall cliff. Okay, so let's draw a picture of this. Okay, so 12 meters is the height of the cliff. And this ball is projected sideways. It's got a purely horizontal velocity, right? And it lands having traveled a horizontal distance of 23 meters. So let's draw this. And it goes out here. And it goes 23 meters this way, okay? So, all right. So what we do for these is we set up this thing here. We got horizontal, we got vertical, X, VI, VF, A, T. And let's fill in the things that are always true. There's always never any acceleration in the horizontal direction, which makes these guys the same. These guys are basically whatever they are, okay? And all we do on this side is just X is equal to VT, basically, right? The triangle, this is just basically a triangle, very simple triangle problem, okay? On this side, though, it's full-fledged, right? So this acceleration is equal to negative 9.8. And then since it's a cliff problem and it's projected sideways, our initial vertical velocity is 0. So now we have two things we know, right? And then we know that the cliff is 12 meters tall. So at the end of the day, we end up going down 12 meters. So don't forget that. There's a minus sign there, a minus sign here. And we have three things on this side. We have only... there are only three things we can know. We can know the horizontal distance. Oh, we do know that, 23, right? We can know this horizontal velocity. These are the same, right? And then we can know the time, okay? So the way this is going to play out, anytime you know the height of the cliff, you're going to find the time using this guy. Right, so that becomes negative 12 is equal to, and then the initial velocity is 0, so this is just 0, right? Plus 1/2 negative 9.8 times t squared. Now, as it turns out, we're very bad at solving this for t. Okay, so let's just do this step by step. The first thing I'm going to do is multiply both sides by 2. And that gets rid of the 1/2. Okay, the next thing I'm going to do is I'm going to divide both sides by negative 9.8. Okay, and then that, by the way, gets rid of the 9.8, and we end up with t squared, right? Okay, so let's look at this. I'm going to go 2 times negative 12 divided by negative 9.8. And this left side is 2.44897. And that equals t squared. And then I'm going to square root that. And I get that the time is equal to 1.56492 seconds. I'm going to write down a lot of digits because I don't want to round. 56492 seconds. And then, of course, time is on both sides, right? 1.56492. All right. And then there's a number of things we need to figure out. Let's figure out this velocity here. Okay. So that this velocity here is just simply going to be the distance divided by the time. Okay. So v is just x over t, and that's going to be 23 divided by 1.56492. 23 divided by, I'm going to go 23 divided by answer. And I get that this velocity here is 14.697. 14.697. Okay, the next thing I want to calculate is this final vertical velocity. I'll need that for this part 3. You'll see. Okay, so the final vertical velocity, I think the thing to use is VF squared. Is VI squared plus 2AX. So VF squared is 0 squared plus 2 times, and then this direction here is negative 9.8. The acceleration is negative 9.8, and then our displacement is negative 12. So I get 2 times, wait, clear, I'm gonna, whoops. Okay, so let's multiply. So 2 times negative 9.8 times 12. Negative 12 is 235.2 is VF squared. So then VF, if we take the square root of that, VF is 15.336, right? The absolute value of VF is 13.336. Whoops. 15.336 meters per second. Now we know, of course, it's going down, so we're going to write negative 15.336. Okay. The absolute value is 15.336, which means it could be positive that or negative that. You know that it's going down, so you put the minus sign on there. Okay, this displacement was down because you knew they went down. Gravity is down, right? That's what all those minus signs are for. Okay, we've answered some of the questions. So what time is the ball in the air? 1.56 seconds is this guy, right? Horizontal velocity, we've answered that, is this, right? And now we need to draw a picture of this, the velocity vector. So I'm going to draw over. And this is 14.697, and then vertically we've got 15.336, and now I need to find the magnitude and the angle. Okay, so the magnitude is going to be, let's draw a little line here. Magnitude is going to be the square root of 14.697 squared plus 15.336 squared. Let's see if I can do that. Square root of left parenthesis, the answer I just got, squared, plus the 14.697 squared. Let's see what I get. 21.24. So I'm getting that this magnitude here is 21.24 meters per second. That, by the way, is the speed that it hits, right? And then to find that angle is going to be tan minus 1 of opposite over adjacent, right? So tan minus 1 of 15.336. Notice that that side is opposite the angle, right? Over 14.697. Okay. Second tan of 15.336 divided by, this will be a number bigger than 45, right? Divided by 14.697. 46.2 degrees. All right. So here's how you show me that you know the right answer. You've drawn the vector, you've drawn an arrow to the right, an arrow down, and then the velocity vector is an arrow. Don't forget to draw an arrow, right? You've labeled the angle that you found. You found that angle, and you found the hypotenuse. Okay, and you've labeled the hypotenuse with what it is. You use units, degrees, and meters per second, and that's all there is to it. Yeah.